Hello everyone, welcome to this tutorial session on mapping file data to Parquet for analytics and machine learning. My name is Chen, and I'm developer of Microsoft C+ AI Health Life Science Cloud and Data Team. My work mainly focuses on building tools and services to empower people to better analyze health and life science data. Most of the data should be in file format, or users need to use some pipelines to transfer their data into FHIR. Then, we help to build some general solutions so they can quickly analyze them in multiple platforms. Today, our tutorial is about mapping file data to Parquet format for analytics and machine learning. And we have about half an hour for the presentation. I prepared 3 topics for today's tutorial. First, I will take a moment to briefly introduce Parquet format for the audience, so we can have a basic understanding of this format, get a sense of its advantages, and add some necessary background knowledge for the following content. Then, we will talk about how to map file data into Parquet format. With some rules, we can make the mapping process smoother and be more general. In the third part, I will give a couple of quick demos on analyzing file Parquet data on the cloud platform. And after all those content, you will have about 10 minutes for the Q&A session. In the beginning, let me introduce some basic concepts of Parquet format as a background knowledge in case someone may not familiar with this data format, and they cannot understand why we want to use Parquet when analyzing file data. The Parquet is created by Apache. From its description, it's an open source, column-oriented data file format designed for efficient data storage and retrieval. Due to the time constraint, I will not introduce the detailed design of Parquet format in this session, but I will introduce some necessary basic concepts which can help us better understand the advantages of Parquet and how to map file data into Parquet format. Parquet format supports complex, nested data structure. From the ground up it was created. The array, object, and the combination of those objects can be smoothly stored in Parquet without information loss. And this format has a set of compression mechanisms. The detailed value will be encoded, and the entire contents will be organized in its own file system. It supported several compression methods. You can choose one based on your needs regarding to the compression ratio and the processing performance. Then, let's look at the column storage. Parquet format uses a record structuring and assembling algorithm to store the complex nested data, so that we can access the specified field among the entire dataset column by column, rather than row by row. This brings us extremely fast query performance. In most data formats, such as CSV, XML, JSON, etc., multiple data are stored in rows. And when you want to get the specified property among your dataset, or let's say you want to query a single column, the row-based structure needs to scan each row and even need to pass it to get the required property. But column-based structure can directly access the required property. Here we can easily see another benefit. Parquet format supports people reading specified columns, and only the value under those required columns will be returned. Will not scan other fields in the dataset. So, to summarize part of the main advantages of Parquet format, it's an open source by Apache, which means it's currently being improved, maintained, and supported among the communities by users and developers. We saw the increased number of platforms support Parquet as their data source. And due to the compression category and well-designed storage system, we can store big data sets with better use of the space. More importantly, it has faster query performance, we can quickly access our interest in the field without involving non-required field in the dataset. Then we come to our second topic, map file data to Parquet. For the general perspective, we have 3 steps to store any kind of complex nested data into Parquet. The first thing is define Parquet schema. As a nested structured data format, Parquet has its own schema. Here is an example schema and its corresponding simple data. The data here is in JSON format, just for better view and better understand. Besides the data types like int string here, the schema have some special keywords. The repeated. This keyword indicates the field is an array, and the group indicates the field is an object that contains some sub-properties. Also, there are some special options keyword. Represent the field can be empty or none. After you have defined the schema, you need to load the data in the memory of the machine. Here you may need to do some conversion works if your raw data schema is different from the Parquet schema you defined. You need to convert every data record to the target structure. Then you need to collect the bunch of the data. For the Parquet format, the compression and column stripping algorithm require the data better be saved bunch by bunch, because the value need to be encoded and be compressed. You may need to set up some parameters depends on your requirements. When writing file Parquet data in the memory to the disk, basically, a large block size indicates a smaller file size, because compression works better on large batch data. But large block size takes more memory to load and deserialize single block size and may lead to some query issues. The final thing is to write data in file system in Parquet format. Apache provides some open source dev resources across multiple program languages. You can leverage them in your projects. Or you can also follow up Parquet definitions, implement a piece of writing interfaces by yourself. I would like to add something about reading Parquet data. This could be a first step to do the analytics job on the dataset. The most common and really useful feature is that this format supports fine-grained read. One nice thing about that is you can read only your interested column or field. The Parquet schema can be seen as a tree, and its primitive type field are the leaves. You can think of the leaf as a column, so we get following columns from above example schema. Let's say we'd like to query the .id, name language code, and name URL to do some analytics task. Only the value under those 3 columns will be returned, and will not involve the other field in the dataset. So, now you know how to store data into Parquet format in general perspective. Here are some gaps you need to handle when you are about to design the Parquet schema for each file resources. I listed some of them here, and we'll talk about how to handle those gaps. Choice types. The choice types are special elements in file data. At one particular point position in your file data, you can have a node of the type X or type Y. For example, for the effective field, the value should be either datetime data type or period data type. The practical data type of the value could be multiple. You can define the Parquet schema for each choice types. They have different field name and different data type, but the schema may become sparse, since at most one choice type will be involved in each resource. Or you can define the schema for the prefix name of the choice types. Set up the data type as a string, then serialize the choice type fields into JSON string when writing file data to Parquet. And you need to do some sparse jobs when you analyze them in the platform. This will make the schema more concise. Recursion. From the file definitions, recursion reference happens at multiple times in file. The sub-properties of some field can be the field themselves. The simple example is that item field can have another item as a property. The Parquet schema cannot handle recursion definitions. The Parquet schema is limited and need to be defined in advance. You can set up the maximal recursion depth and define the string field in Parquet schema, then also serialize the field deeper than the maximal depth. Just use the JSON string to store them in Parquet. The extensions are special and complex fields in FHIR. Users can follow up the rules to define the extension by themselves. So extension schema can be various among companies or organizations. In order to create the general solution to map FHIR data into Parquet, you can still define the string field in Parquet schema for extension field, then serialize the extension field. Store them as a JSON string in Parquet data. The last one is primitive extension, which means the extension on primitive types. For example, here birth date is a primitive data type value, and its primitive extension be prefixed with an underline. Almost every primitive value can have the primitive extensions, but those extensions are rarely being used, and the extension value in the type of analysis is even more marginal. If you create schema for them, the whole schema size could be double or even triple, because every single primitive value has the primitive extension in terms of the FHIR definition. The appropriate way is to omit them in Parquet schema, and find a special way to handle them if you really need those fields. Another thing you may need to pay attention is to load data periodically. As we said, you'd better load bench data in the memory and write them in Parquet. The periodically load data can give you a bunch data each time. Your data may be streaming uploaded to FHIR service. For example, you have some IOMT device, and their data be synced up to service in nearly real time. You need to set up periodically trigger time to write FHIR data into Parquet bench by bench, so that the store and the query performance can be better. Now, the FHIR data can be written to Parquet with nearly no information loss. We have implemented an OSS project. We have implemented an open source project based on above steps. Define schema, bench load the data periodically, make some conversions, and write them into Parquet. You can see the Parquet data here are generated by our open source pipeline. They've been stored in Azure Storage account, and each Parquet file contains the bench data for a particular file resource. We use the hierarchical namespace to split the dataset into multiple partitions by the date time. You can also do the similar operations to better manage the dataset. Then, we come to the last topic in today's tutorial: analyze Parquet data. Parquet is becoming a popular format among cloud platforms. Here I will give some demos on Synapse Serverless SQL Pool for analytics of FHIR Parquet data, and then on the Spark platform to do the machine learning task on FHIR Parquet data. All the FHIR data being involved in the demos are synthetic, random generated. When you want to do the analytics works on FHIR Parquet data on the Analyze platform, here we take Azure Synapse as an example. The first thing is to initialize the database and create an external table that links to the Parquet data in your storage. Here are some general steps for the Synapse workspace to access the Parquet data in the storage. In Synapse Serverless SQL Pool, you need to create a new database, then move on that. Create a master key on it. The master key is used to protect the certificates and the asymmetric keys in the database. We need that so we can create the credential to the storage. Then create a scope credential. Set up the identity type as managed identity, which means to use managed authentication to access the data. And next, create an external data source. The location should be set up to your Parquet data container, and specify the credential as the scope the credential just be created. The last step is creating the external file format in your database. The format type is Parquet. You can also create a file-specific schema in your database as a category of the file-related tables. The detailed step and some explanation for steps here can be found in the document of Azure Synapse. Then you can create external tables on the database. Use the create external table keyword and set up the columns based on your Parquet schema. Also, fill the location, data source, and file format information, which are being created just now. Each file resource have different definitions, so have different Parquet schemas. You could implement some scripts to pass the Parquet schema you defined and generate SQL languages to create a table for all the file resources. We implemented one in our open source project. This will auto-initialize the database environment and create external tables for all the resources. You can refer it and or you can just use it. When the data is ready, and you successfully create tables for file Parquet data on the storage, the table metadata will be listed in left board, and you can query them to do analytics jobs per your requirements. For example, we select part of the patient in the serverless SQL pool. You can see the results are returned. The none indicates the empty value in raw file data. You can only select interesting columns. That will be faster because Parquet is a columnar storage. One special thing you may notice is that here name is a JSON array string. The array elements in Parquet cannot be auto-flattened in SQL pool. Here, by default, Azure Synapse can help us automatically serialize the array object in JSON string, and we need some additional steps to access the detailed value in them. One method to better handle the array element is create another table or view for them. For example, to flatten the name property in last query, you can create a view. Here we use the open row set and still fill the location, data source, and data format of your file Parquet data. Then use OpenJSON keywords to pass the array element to multiple items. Here you need to tell the JSON path for each detailed value. Then use cross-apply to join the items with raw column together. Then query the view. You can see that array elements are being passed into multiple records. Some of them have same ID if they belong to same row resource. Now, you can join the table and the view to analyze the detailed value in array elements. Also, our open source script will help you create views on all the array elements appear in the first level of the resource data. You can refer it for more details. Creating additional views could be a general way to handle array elements in Parquet, but it needs some effort and cannot be done like a fast try when you just want to view or check the data. Another way to handle the array element, and even can handle all the JSON string elements in Synapse serverless SQL pool, is to use JSON functions. Here, we use extension field in patient as an example. You can say extension is an array and it has further nested objects. You can use JSON value or JSON query to handle all the JSON objects in your FHIR Parquet data. They all take the value and the target JSON path as the input, but JSON value will return the primitive type value, while the JSON query will return the JSON object as a string. Use them in your query. You can quickly check or analyze the detail value in your FHIR Parquet data. Then, we look at the machine learning works on FHIR Parquet data. We take the Synapse Spark pool as an example here. In this demo, we use some simple FHIR Parquet data to train the light GBM model. The data is randomly generated and the class label has no particular means. Spark has well supported for Parquet format. You can simply load and display your entire FHIR Parquet data in Spark. Or you can just load your interesting columns. And you can easily view the schema of your loaded Parquet content. The schema is complex here. The loaded data from contain nested objects. Then, in common procedures, you need to do some pre-process before you use your raw data to train model or do some other things. After this step, you get the flashed and flattened data. You can view and check your data again to compute some static information among the dataset to make sure the data is appropriate for the training and testing. Here include some visualized results. Then, you can train the machine learning model on your FHIR Parquet data. Split the data into train and test set. Do some feature engineering and train the model. After you get the model, you can see the information of the model and prepare your next plan. Let's do a summary. Parquet format is an open-source format, and being well supported by different platforms. It has compression and column storage features. You can efficiently do analytics works on it. Map file data to Parquet. You need to handle some gaps, and define Parquet schema. Load and write data to the disk in Parquet format. When you do the analytics task with FHIR Parquet data, You can use different platforms and leverage the JSON functions if you store some field as a JSON string in Parquet. I hope this tutorial would be useful to you if you want to do analytics and machine learning works on FHIR data. Here are some resources that we reference in this tutorial. You can find those resources in the slide page. Finally, here's my contact information. Please feel free to contact me if you want to get more about this topic. Now we can open and begin our Q&A session.
Thanks, Quan, for your very nice presentation. I see you're already answering the chat as well. I am not seeing any questions in the Q&A coming in, but all participants feel free to answer them or to ask them. Maybe there are some questions from the live event.
Yes, I have a question. So the example you gave with patient name, that is a repeating value. And I saw within the tables that are created, you've got a patient ID, but I didn't see like a row ID or something like that to make it unique. So how are you handling repeating data with JSON serialization?
Yeah, hi. Can you hear me?
Yes.
Hello? Yeah, okay. So when you encounter the repeated the value, in fact you can manage because when you when you create the views or you use the JSON value or JSON query to handle the repeated value in Synapse SQL service SQL pool, you just define the results by yourselves. So you can define the row ID and you can define the unique row ID when you create the views, or you use the JSON value or JSON query and return it in results. Yeah, in your example, I just not use that because I use the join keywords to join the value from the view and to the row tables. So I just don't use the unique ID because but you can define that if you want, if you need it in your scenarios. Yeah.
Hi, thanks for the talk. I'm curious if you have any have you ever done anything with references, or for example, if you want to analyze like maybe observations that were authored by a certain attribute of a practitioner or something.
I'm sorry, I'm not really, I'm not quite clear of your question. Can you repeat it again?
Yeah, so in the FHIR resources, you can have references to other types of resources, right?
Yeah.
And I'm wondering if you've ever dealt with anything where you want to analyze based on the referenced resource.
Yeah, you for example, you mean for example the observation can refer to the patient resource in FHIR definitions, right?
Yeah.
So in that case, you can select your interested columns in patient in different resources, for example, in patient and in observation or in the encounter, and you can join them together with the reference key with the reference value in those resources, because if your observation record refers to a patient record, so your observation record should have the refers value as point which links to the patient ID, right? The pattern maybe becomes maybe like a reference and plus to the patient ID, and you can use it in your SQL query to join them together in the results and return it to do some analytics works.
Okay, got it. Thanks.
Yeah, thanks.
It doesn't seem like there are any more questions in the room.
Okay, thank you. I didn't see any questions coming in from the Q&A as well. So I think this is the end of the sessions. Thanks a lot, Quan, for the presentation. And have a nice day, or do you want to add anything?
Okay, thanks for your help. Yeah.